In this video, we will be discussing quadrilaterals and its types and the properties of its types. So as we know that quadrilateral is a polygon having four sides. So these are all quadrilaterals. The first one is trapezium, the second one is parallelogram, this one, third one is rectangle, fourth one is sphere, this fifth one is a rhombus, and this sixth one is a kite. So let's discuss one by one. First is trapezium. Now trapezium is a type of quadrilateral in which one pair of opposite sides are parallel. So here in this trapezium DC, this side DC is parallel to this side AB. So this is one of the basic aspect of the definition of the trapezium, and that is that its one pair is parallel, and here DC is parallel to AB, and this is the in fact the definition of trapezium, a quadrilateral having one pair of parallel lines. Now the second figure is parallelogram. Now there are many properties of parallelogram. The first one is that its opposite sides are parallel. Now AB is parallel to DC. Not only AB is parallel to BC, but AB is also equal to other DC. AB is parallel to DC, and not only AB is parallel to DC, AB is also equal to DC. Similarly, AD is parallel to BC, and AD is not only parallel to BC, it is also equal to BC. That is, AD is equal to BC. Second thing, if we draw the two diagonals of parallelogram, now this is the diagonal, one of the diagonal of the parallelogram, and this is the other diagonal of parallelogram, and these two diagonals will be not equal. If the quadrilateral is a parallelogram, then the diagonals of the parallelograms are not equal, but they bisect each other. These two diagonals, that is D, B, and A, C, bisect each other at this point. That is, this is the central point of both the diagonals. D and B having this central point, and A and C having this same central point. And we say that AC and DB, that is the two diagonals, bisect each other, and these diagonals are not equal. If the figure is a parallelogram, then the diagonals will not be equal, but they bisect each other. This is the central point. Now, this is a familiar figure of rectangle. Now, in a rectangle, two pairs are parallel. That is, AB is parallel to DC, and AD is parallel to BC. Similarly, AB is equal to DC, and AD will be equal to BC. And if we draw the two diagonals of this rectangle, that is AC and DB, these two diagonals are equal in length, and also the diagonals bisect each other. That is, this point will be the center point of both the diagonals, or diagonals bisect each other, and all the angles of rectangles are of 90 degree. So this angle D is of 90 degree, C 90 degree, A 90 degree, and B 90 degree. The next figure is a sphere. Sphere having two opposite pairs which are parallel to each other. The DC is parallel to AB and AD is parallel to BC. And secondly, all the sides of a square are equal and all the angles are of 90 degree. These are all 90-degree angles. And if we draw two diagonals of squares of this square, or of that matter any square, the diagonals are of equal length. That is DB is equal to AC, and they bisect each other. And this must be the central point of both the diagonals. And not only they bisect each other, they bisect each other at 90 degree. That is, this angle will be of 90 degree. And this figure, the fifth one figure, is called rhombus. And when it will be called a rhombus? When all its sides are equal. That is, this side, this side, this side, and this side. All these sides are equal. And two pairs are parallel. That is, DC is parallel to AB and AD is parallel to BC. This is another property of a rhombus, and diagonals are not equal in length. That is, if we draw two diagonals, that is this diagonal DB and AC, these diagonals are not equal in length. And opposite angles are equal. Like in parallelogram, angle B is equal to angle D and angle A is equal to angle C. Similarly, in the rhombus, the opposite angles are also equal. That is, angle B is equal to angle D and angle A is equal to angle C. The sixth one. Now, this figure is called kite. Now, in kite, now these two sides are adjacent sides. They meet each other at this point, and these two sides are adjacent sides. So in parallelogram, these adjacent sides are equal. These two sides are adjacent, they are equal. Similarly, these two sides, that is AD and DC are adjacent, they are also equal. So in kite, the adjacent sides are equal. Only if we draw two diagonals, that is this diagonal BD and this diagonal AB, these diagonals are certainly not equal in length, but they bisect each other. Uh, in fact, the bigger diagonal, that is BD, bisect the smaller diagonal AC at an angle of 90 degree. And one more property of the kite, that these two angles, this angle and this angle, these two angles are equal. So one pair of interior angle of a kite are equal. These are non-vertex angles. This B angle and D angle are called vertex angles. These are not equal. These are non-vertex angles, A and C, and they are equal. In kite, these non-vertex angles are always equal. So these are some of the quadrilaterals and their properties.